In this video, I want to define the least common multiple as well as show how we can find it. So the least common multiple of two or more numbers is the smallest counting number that is a multiple of all of the given numbers. As an example, let's consider 6 and 8. The multiples of 6 would be 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 25, 6 times 5 is 30, etc. 8, well, 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, 8 times 5 is 40, and we can keep going. The least common multiple is going to be the smallest number that appears on both of these lists. So it'll be the first number that appears on each list. And this is one way of finding the least common multiple. Just list out lots of multiples until you find one that does appear on both lists. But let's look at some other methods. Let's start by looking at the slide method to determine the least common multiple. Let's consider 8,800 and 10,000. My slide method does start with a table with the first column empty. And we look at things they have in common. We know these have a 10 in common. 8,800 divided by 10 is 880. 10,000 divided by 10 is 1,000. We can keep going. They have a 10 in common. 880 divided by 10 is 88. 1,000 divided by 10 is 100. We can now see that they have a 2 in common. 88 divided by 2 is 44. 100 divided by 2 is 50. And then finally, they have another 2 in common. 44 divided by 2 is 22, and 50 divided by 2 is 25. And these two have nothing in common. And I could have done this in fewer steps. I could have seen that they had a 100 in common to start with, or a 4 right here. So it doesn't matter which steps you do or which order you write these in. When I find my greatest common factor, I multiplied these 4 numbers. But to find the least common multiple, I'm going to multiply these as well as these down here. So in this case, my least common multiple, 10 times 10, times 2 times 2, times 22, times 25, which is 220,000. Understanding how this works is a little bit tricky. So if I look at this, 10 times 10 times 2 times 2 times 22 is 8,800. 10 times 10 times 2 times 2 times 25 is 10,000. So the product of the numbers on the left and the numbers on the bottom row of the slide must be a multiple of the initial numbers. And since we don't repeat the factors that the two initial numbers have in common, in particular these factors here on the left, we get the smallest possible multiple of the initial numbers. So it's a little bit tricky to understand why this works. Next, let's look at the prime factorization method. Let's consider 120 and 156. We know the prime factorization of 120 is 2 cubed times 3 times 5, and the factorization of 156 is 2 squared times 3 times 13. So when I find my least common multiple, I'm going to start by writing down the entire first prime factorization, and then I go to the next one. I have 2 2's. Well, down here I've already written down 3 2's, so I've already accounted for those 2. I've already accounted for a 3, but I'm missing a 13. So my least common multiple would be 2 cubed times 3 times 5 times 13. Just like with the greatest common factor, I can do this with a Venn diagram as well. We know that 120 has 2 2's in common and then an extra 2. It has a 3 and a 5. 156 has 2 2's, a 3, and a 13. And now, for the least common multiple, I'm just going to multiply all of the numbers I've written down. 2 times 5 times 2 times 2 times 3 times 13. And if I rearrange this, I do get what I was claiming was the least common multiple before.